Adelante, doctor Rafael.
Good afternoon, everyone. The subject of my talk is a methodology for teaching how to tackle ill-defined problems in engineering. I would like to start by mentioning one of the main points of my presentation, which is that having a clear worldview, a Weltanschauung, is the key for tackling ill-defined problems. You may agree with me that challenge-based learning is an effective learning framework in which challenges can either be local or global real-world problems, right? However, in many real-world situations, the problem identification is as important as finding a solution to the problem. And that leads us to ill-defined problems, which are very common in real-world situations. Ill-defined problems, opposite to well-defined problems such as solving an algebraic equation, has multiple problem formulations. The ill-defined problems also have vague or unstated goals. Solutions are not true or false, correct or incorrect. There are many stakeholders with different points of view. Problems are very often interconnected, and also problems might be interdependent. And here we come to that main point of this talk, which is the worldview. In many engineering problems, we attempt to solve a problem by developing models, right? Just as in the explanation of Professor Rolando. With that model, we find a solution, we simulate, we optimize, and that solution is then applied to the real world. What is less obvious is that we are actually moving between the real world and a systems world. Just to give you an example, if you were to solve supply chain management problems in which a supply chain is composed of different elements such as factories, distribution centers, warehouses, and customers, we tend to represent this in the systems world as a model composed of nodes and arcs, right? And from which this view of the world, we develop mathematical models, very often optimization problems, and then we find a solution to a problem that we want to solve. What is less obvious is that we are actually looking at the real world through a worldview or Weltanschauung, right? In the paper, I explain an explicit Weltanschauung in which the system is composed of behaviors of different activities, the physical structure, the operation and management of the system, composed of activities and participating physical objects of those activities. Where is the activity located? Who are the performers or the doers of the activities? What are the resources that existed before the activity, but that were changed by the activity? What are the instruments that are used by the performers who carry out the activities, and so on? So in the proposed methodology, we're actually moving initially from the real world to the system world using the Weltanschauung, and at the end, we will move from system world to the real world. The methodology is composed of 5 phases. In phase 1, students attempt to understand the problem. Working on the right hemisphere of the brain, in which students look at the holistic view of the situation, the problem. They try to find patterns and connections, and they move on to phase 2. Now we are working on the left part of the brain, right? They attempt to explain rationally. They identify the stakeholders. They try to understand the stakeholders' viewpoint. Then we move on to phase 3, in which students define the problem. They attempt to formulate the problem. And then in phase 4, they solve the problem based on that formulation. Finally, in phase 5, students interpret the solution, and this is an attempt to move back to the real world. So notice that from phase 2 to phase 4, the instructor uses scaffolding to support the student process. And this is done by means of question prompts. Some examples of question prompts are as follows. For instance, in phase 2, the instructor asks students about the system components. What are the elements of the systems? How are the components connected? What are the activities, the resources, the instruments and performers of the activities? Who are the stakeholders? What are the needs of these stakeholders? In phase 3, the instructor asks questions such as, what information is available or what information is missing? What are the cause-effect relationships? How to measure the success of any possible problem solution? In phase 4, the instructor uses another type of question prompts, such as, what are the relationship between the variables? How does one variable affect another? What are the constraints that we have to think about? What are the advantages or disadvantages of each solution, right? So we decided to implement this methodology in 3 different instances. In the first instance, students work on an engineering economics problem, trying to formulate the problem and solve it. In the second instance, students analyze activities of an existing factory, identify issues, and then they propose technological and business-related solutions. In the third one, the third one was about an I-week, a Semana Y activity in which students use design methodologies to come up with innovative product designs. Because of time constraints, I will focus on the first case study, in which participants were 8 undergraduate students, all majoring in industrial engineering. Students were given a document describing the basics of the problem, but were not given the criteria to evaluate the solution, neither the specific problem formulation. They spent an average of 2.5 hours per day for 2 weeks. They were split into different groups working in separate classrooms. The information that was given to the students was obtained from a real world situation in which a person has a mortgage from the bank with an annual interest rate to be paid in a maximum period of 10 years. This person has already some money deposited in an investment fund that generates an annual return in monthly payments. And the students are also given information about the main income and expenses. It happens that the bank has a mechanism in which extra payments on the mortgage are possible, and this can shave some years off and reduce the total interest. So students have to find the best way to use the net income in terms of what to do with the deposits and the extra payments to the mortgage. So in phase 1, students started discussing the problems, they worked in teams, and attempted to solve it. Remember that we are working on the right hemisphere of the brain. So immediately, students got stuck, not being able to move forward. In phase 2, the instructor used question prompts related to a stakeholder, and students start to think about the needs of the stakeholder. But they decided to include cash flows, all the cash flows they identified in a single diagram, and they got stuck again. So the instructor used question prompts associated to activities. So he asked students to draw pictures representing activities, each with the resources, performers, and instruments. And they were able to identify an activity for the settlement of the mortgage, an activity for the accumulation of money in the savings account, and that enabled them to come up with 2 separate cash flows, which was the key to formulate the problem and solve it efficiently. So moving on to phase 3, students start identifying variables. They investigate different relationships between the variables. So they realize that some variables can be calculated and some variables are given. and some variables might actually be defined during the solution. They define the evaluation criteria as the future worth at year 10, and this is common for both groups.
5 minutos más, doctor.
So in phase 4, students attempt to formulate the problem. In both groups, they formulate the problem as an optimization problem. They discover, however, that there are many ways to formulate the problem, and they got stuck again. The instructor asking questions about the different relationship between the variables, students discover that there are different approaches of formulating the problem. Group 1 starts by defining a simplified version of the problem, a baseline. However, after that, they formulate the problem using 120 variables, realizing that this was a very complex problem formulation. They move on to a simplified version using 4 decision variables that were associated to the deposits to the fund. Group 2, on the other hand, right away starts with a simplified version of the problem with 1 variable related to the extra payments. That allow them to formulate the problem later in a more realistic manner using 3 decision variables. And they are using 3 decision variables instead of 4 because once the decision variable used in group 2 is about the extra payment, and the extra payment stops once the mortgage is settled. It's interesting to find that both groups reported similar results about the future worth. Both groups formulated the problem as an optimization problem and used Excel to solve it, to find the numeric solution. However, group 1 also developed a C# program to verify the solution, sorry. In phase 5, students explain the results. And this is very important because very often in many engineering courses, students remain in the systems part. They are not able to explain their results using the vocabulary of the stakeholder. So phase 5 emphasized the need to explain using the vocabulary terms that the stakeholder can understand. To conclude, having a clear Weltanschauung, a worldview, is a key for tackling ill-defined problems. And in all 3 cases, students displayed a much higher level of engagement in comparison to traditional classes. The students were able to define the problem with little or no help from the instructor in some cases. And the findings suggest that the students can more easily connect the problem with what they learned in other courses, such as in optimization, in the case of the engineering economics problem. I would like to end with a quote from Marcel Proust about the true journey. So the true journey of discovery doesn't consist of searching for new landscapes, but in having new eyes. Thank you very much. So now I'd be very interested to hear any questions or comments. Spanish is welcome as well.
Muchas gracias, doctor Rafael Batres. Si alguien tiene alguna pregunta, puede abrir su micrófono.
Hola, hola, buenas tardes. Mi nombre es Roberto Durán. Tengo una consulta. Cuando ustedes comparan su método de, no sé, 6 etapas, si no me equivoco,
Las 5
lo compararon,
fases.
¿Perdón?
5 fases, son 5 fases.
5. ¿Lo compararon con algún otro método o simplemente con la enseñanza tradicional?
Con la enseñanza tradicional. De hecho, en los cursos tradicionales de ingeniería económica, los estudiantes no, por lo general, no tienen la oportunidad de conectar, por ejemplo, con la parte de optimización. En realidad todo es muy lineal. Por cierto, olvidé mencionar que aunque son 5 fases, es un proceso iterativo. En realidad, en varias de las etapas los estudiantes regresan.
Ya. Y dentro de esas fases, ¿cuántos equipos se formaron? O sea, dentro de los equipos, porque mencionaban los...
Ok. No, en realidad fueron 2 grupos. En cada grupo había un solo equipo.
Ya, perfecto. Ya me queda más claro. Gracias.
Gracias a usted.
Oye, Rafael, habla Ricardo Ramírez, ¿cómo estás?
Bien, Ricardo, ¿cómo estás?
Una pregunta, y es la misma, de hecho, que ahorita al colega chileno, profesor chileno que te pregunto ahorita, le hice la misma pregunta, ¿no? En este tema de los challenge, tenemos ciertas competencias que desarrollar en términos de contenidos. Y a veces nosotros como profesores usamos mucho los métodos intuitivos, ¿verdad? Los métodos de solución de problemas, digamos, intuitivos, de acuerdo a la experiencia, un poco el feeling, ¿no?, que tenemos de resolver problemas de ingeniería.
Sí.
¿Qué tan difícil es usar, digamos, este método, ¿verdad?, o combinarlos o convivir, digamos, con métodos intuitivos, Rafael? ¿Qué nos recomendarías hacer en este caso para los profesores que usamos más la intuición?
¿Me puedes dar un ejemplo? ¿En qué caso utilizarías la intuición, Ricardo?
Sí, sí, por ejemplo, en problemas mecánicos, ¿no?, donde
Ajá.
tienes que resolver seleccionar parámetros de diseño, ¿no?, para que el sistema mecánico se comporte de cierta manera. Entonces,
Sí.
nosotros pasamos por ejemplo, con modelos mecánicos simples de un grado de libertad. Después decimos, no, pues a lo mejor dos
Ok,
o
ok.
tres, y luego simulas, y luego haces un estudio de sensibilidad.
Sí,
Lo verificas con algún parámetro de desempeño y así, ¿verdad? O sea, un poco
ya
la...
veo, ya veo. Sí, 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 sí. No, de hecho, todo eso realmente está ocurriendo en el proceso. Lo que es importante es que los alumnos tengan la posibilidad de entender primero bien el problema, ¿no? Eh, al- algo que, algo que enfatizo mucho es la parte de enfocarse en el problema al que deben enfocarse. Les comento con un ejemplo de una misión al lado oscuro de la Luna por la Unión Soviética, en donde pues el vehículo tiene un foco y en el momento del aterrizaje el foco se rompe. Entonces los ingenieros empiezan a trabajar sobre materiales más resistentes o de qué manera pueden proteger al foco para que no se rompa. Pero están pensando en el problema equivocado, ¿no? Porque ¿para qué es el vidrio del foco? Es para mantener un vacío y que el filamento no se consuma con el oxígeno del aire. Y en la Luna lo que más abunda es el vacío. Entonces, el cómo resuelven el problema, puedes utilizar muchísimas herramientas. Lo importante también es guiarlos en encontrar el problema al que deben estar enfocándose, ¿no?
Gracias, Rafael.
A ti, Ricardo.
Tenemos tiempo de una pregunta más, si alguien quiere hacerla. Me parece que ya no. Muchas gracias, doctor
Hay,
Rafael.
hay una
Ah,
en
sí,
el
hay
chat.
una pregunta. Adelante.
Omar.
¿Puede
Sí,
leer la
buenas
pregunta, por favor?
tardes. Felicidades al doctor Batres. Mi pregunta sería, doctor, ¿cómo podría, existe un checklist o existe una recomendación para poder validar los resultados de su trabajo en ese sentido para poder llevar esta experiencia a otros contextos? Es decir, ¿cómo comparar un curso normal con un curso donde se lleva a cabo esta innovación?
Sí,
No sé si me
yo creo
expliqué.
que
Gracias.
en este caso sí depende mucho del caso en particular. Por ejemplo, en el caso del diseño de producto, utilizamos las evaluaciones que vienen de semana I de los alumnos y algunas encuestas también para entender el grado en el que se desarrolló más la creatividad o en el que pudieron desarrollar más innovaciones. Pero sí
Gracias,
dependerá
doctor.
de cada caso. Edgar, muchas gracias.
Muchas gracias. La profesora Nancy tiene levantada la mano y con eso vamos a terminar. Adelante, profesora Nancy.
Sí, muchas gracias. Yo soy psicóloga, me especializo en cognición y es un gusto ver ejemplos como el de usted, doctor, de
Muchas
cómo
gracias.
de verdad las aplicaciones de la ciencia cognitiva pueden tener cabida en la ingeniería. Yo con mis alumnos en la Facultad de Psicología veo toma de decisiones, veo todo esto que nos explicó y bueno, nos ejemplifica muy bien cómo el pensamiento, la cognición nos ayuda a ubicar los problemas y que invitemos a nuestros alumnos de todas las áreas a concentrarse y a buscar el problema adecuado. Muchas gracias por su ejemplificación y seguramente por ahí
Muchas
le
gracias.
estarán dando lata a mis alumnos. Gracias.
Oh,
Muchas
adelante.
gracias.
Muchísimas gracias.
Gracias.
Muchas gracias a los dos y
Solo un comentario, Rosa, con
Sí.
respecto a lo que acaba de decir la maestra Nancy y a colación del gran trabajo de Rafael. Yo coincido con que lo más importante son las preguntas que los mismos chicos hagan, que las mismas respuestas. Es decir, si ellos están haciendo las preguntas correctas, sí, todo lo demás creo que puede fluir muy bien, ¿verdad? Entonces, completamente de acuerdo con la maestra Nancy y el doctor Rafael. Gracias.
Muchas gracias por su
Muchas
comentario,
gracias.
profesor Ricardo.